welcome to Opportunity X, where today we will be learning about soap-powered boats and how they relate to surface tension. So, some scientific principles behind today's experiment are cohesion and adhesion. Cohesion is when particles of the same substance are going to attract each other. And this is something that we'll see in surface tension when water molecules attract each other and also when mercury atoms attract each other. Adhesion is when particles of separate, different substances stick to each other. So try to think of some sticky things in your life, in your everyday life, and you can pause the video here, think of a couple of examples, and we'll move on. So some answers to that might be tape and paper, stickers, glue, sticky tack, and really any surface. Some of the scientific principles behind surface tension is cohesion. And cohesion is behind surface tension because water molecules are attracted to each other. And in mercury, the reason that these atoms are attracted to each other is because they have strong metallic bonds, whereas water molecules are attracted to each other because water is a polar molecule. And we're going to go more into detail into this later in the presentation. But generally, it's because since water is a polar molecule, it forms these hydrogen bonds with each other, and this causes the water molecules to want to get closer and closer and closer. And as they get closer, they minimize the surface area and they form this tiny little bubble that we call surface tension. So, hydrogen bonds. You don't really need to know about these too in depth, but generally, when we see a molecule of water, well, everyone knows that it is two atoms of hydrogen and one atom of oxygen. So a hydrogen bond, by definition, is a type of chemical bond in which the hydrogen atom has a covalent link with an electronegative atom from a link with another molecule that has an electronegative atom. And of course, some examples of electronegative atoms are fluorine, nitrogen, and oxygen. So these water molecules are attracted to each other in cohesion because of hydrogen bonds as mentioned before. So right here, let's just look at the structure of a water molecule first. So we see that we have those two hydrogen atoms and that one big electronegative atom, which is oxygen. And some of you might be wondering, well, what does electronegative even mean? So just think of it as oxygen having all the electrons. So we know that in an atom, there's the proton, which has a positive charge, electron, which has a negative charge, and neutron, which has a neutral charge. Pretty kind of obvious based off of the names. So when we say electronegative, we basically just want to think that the oxygen has all of these electrons surrounding it on that side. So the oxygen is going to hoard all of those electrons, and this is based on placement in the periodic table, and this is the part you don't really have to worry too much about. Just know that oxygen, fluorine, and nitrogen are all going to have more electrons with them than hydrogen. So hydrogen, because when we have a more negative side to something, it has to be balanced out, right? So since the oxygen side of that water molecule is going to be more negative, the hydrogen side with the two hydrogen atoms is going to have a more positive charge. And we see that denoted by the two positive markings near the hydrogens and the negative markings on the oxygen. Okay, so how does this play into hydrogen bond cohesion? Well, of course, after hearing the word hydrogen bonds, you might think, okay, it's a bond because hydrogen might be involved in it. And if that is your guess, you're correct, because the positive side of that water molecule is attracted to an electronegative atom that might be in a molecule with other hydrogens nearby. That molecule might be water. So when we see that positive hydrogen side of that water molecule, it gets attracted to the negative oxygen on another water molecule. And you can just imagine that when the positive and the negative see each other, they become attracted to each other, just like magnets. And they become closer and closer and closer, and that is the concept behind cohesion, and the bond is the concept behind hydrogen bonds. So surface tension, this is where the money is at for our presentation. And surface tension is when, so think about these water molecules, and they're trying to get closer and closer and closer to each other. And as they get closer and closer to each other, they minimize the surface area because they're minimizing the space between them. And especially, surface tension exists because if you look, say we have a fish tank and it's full of water. In the middle of the fish tank, if I pick out a random water molecule, there's water molecules surrounding it on all sides. It's bonded with all those waters. So, but if we move up to the top of the fish tank, we see that the water molecule on the very, very top of that fish tank does not have any water molecules on the top. There's just air there because, it is the surface. So because it has less water molecules surrounding it, this causes its hydrogen bonds to become stronger. So it's trying to cling to all of the water molecules around it in any other circumstance, and it's not clinging to the air. So it moves even more closer together than the water molecules that are in the middle of the fish tank might. And so these cohesive bonds between side-by-side water molecules on the surface are therefore stronger, which causes surface tension. And here are just some examples of surface tension that you might see in your everyday life. It'll be at the top of your water bottle. I'm sure most of you have seen this when you've unscrewed a cold water bottle or a warm water bottle, any kind. You can also see this in those spiders that will walk on water. I believe they're called water gliders, and they are also the reason that bubbles are round, because the sphere is the 3D shape with the smallest surface area. So because surface tension minimizes surface area, this means that the bubbles that are on the bubbles that we see due to surface tension are going to emulate that. So here's just a little quiz for you guys. You can just test your knowledge so far before we go into the procedure of the experiment. And right here, just pause the video, answer these questions maybe on a piece of paper or as a class, and you can continue and see the answers. Alright, so the answers to these questions are hydrogen bonds. So why are water molecules attracted to each other, and why is there cohesion between them? Because that hydrogen is going to attach to another electronegative oxygen that is in another water molecule. The other electronegative elements are fluorine, nitrogen, and oxygen. And some applications of surface tension you might see in your daily life are bugs on water, top of water bottle, round bubbles. And then the definition of adhesion is just the attraction between particles of different substances like tape, think of sticky tack, glue. And cohesion is when particles of the same substance are attracted to each other. So think of mercury. Those atoms are attracted to each other because of these strong metallic bonds between them. And then cohesion between water molecules is due to hydrogen bonds. And the greater the surface tension, we were talking about how those water molecules like to be closer and closer together, especially since they have no neighbors on top. So this minimizes their surface area. Alright, so now we're going to gather all of our materials. So first you're going to need a foam tray. When I say foam tray, I just mean if you have a foam bowl or foam plate, then you would be able to use that. And then also get a container and fill it 3/4 of the way with water, some liquid dish soap, a toothpick, water, or scissors. If you do not have any foam, then you can also use aluminum foil and fold it over enough times so it has the thickness of about 1/4 of an inch. And then I would also, if you do not have liquid dish soap, you could use laundry detergent. So take a minute to pause here, get those materials, and then we'll get on with the procedure. Alright, so first thing we're going to do is cut the foam tray into this shape. You want to first cut out your foam bowl so that the top curved part is gone and that it's just the bottom circular shape, the bottom circle. And then out of that circle, you're going to cut a rectangle and then cut a pentagon, or you could just cut a pentagon straight out. So then next, you're going to cut a somewhat triangle. Try to cut a triangle, but leave a little bit of space at the corner that is touching the bottom of the pentagon, so that will make a notch that we can move our toothpick through. So make sure it's wide enough for that. And then next, you should coat the notch cut into the back of the boat with the dish soap. So just dip your toothpick into your dish soap and coat that notch very well. The more soap you use, that might affect how much your boat moves. Also, the type of water you use will affect it. And fill 3/4 of the container with water. And then place that boat into the water and it will move forward. And the reasoning behind this procedure, so consider this statement as you guys go through the rest of the experiment. Soap is a surfactant and will break the surface tension of the water, creating a force that will propel the boat forward. So think about it like the soap, just like how soap, when you put it on your hands, it breaks up the oil and film. When soap is on this boat, it will break up that surface tension and move it out of the way so that the boat is able to travel more easily. And so you can either pause the video here, take a couple minutes to finish up your experiment, or even start it if you're waiting for us to go through the instructions. And if you're finished, you can keep on continuing with the presentation. Alright, so here are some lab questions to consider. Number 1, what did the soap do to the surface tension? And how did the soap power the boat? And you can either discuss this as a class, or you could just listen to the explanations at the end. How do you think the experiment would be affected if we used more soap, different kinds of soap? And how would the experiment be affected if we used different kinds of water, low, medium, and high surface tension? So for the first one, the soap is of course breaking up that surface tension, so it's making it easier for the boat to travel. And how would the experiment be affected if we use more soap and different types of soap? For different types of soap, it really depends on how good of a surfactant it is. And if you use more soap, yes, it will travel for longer, but of course, this is not a long-term boat. It will eventually stop once you run out of soap on your boat. However, if you use too much of an excess of soap, your boat might not travel at all. And if your boat is wet and you put it into the water, since there's already water molecules in your boat, then it will not travel at all, regardless of how much soap you put in. So it's all relative. And then, how would the experiment be affected if we use different kinds of water, low, medium, high surface tension? In terms of high surface tension, it would be harder for the boat to travel. Assuming we use the same amount of soap for the low, medium, and high surface tension, it would be harder for the boat to travel in high surface tension because it has more surface tension to break up, more bonds that are stronger. And then low surface tension, it would be easier for that soap to break up, so it would travel faster. And then medium would be right in the middle. Alright, here are some applications of surface tension, and then we will be done. The first application is bugs walking on water, as we showed you before. And another application that you might see is how surface tension keeps air in your lungs moist because it's trapping that moisture, since those water molecules are going to stick together in the inner layer of your lungs. And then disinfectants that are used, since disinfectants like soap are made to have low surface tension, so they can act as a surfactant and break up that film. So thank you guys for watching. Hope you enjoyed this presentation and this experiment. And make sure to like, comment, and subscribe.